If we want to eliminate our greenhouse gas emissions and decarbonize our energy systems, we need to use a future fuel that doesn't have carbon in it. Hydrogen and ammonia are obvious candidates as carbon-free fuels, and I've been advocating for their introduction for over 20 years. My name is Dongke Zhang. I'm a senior academic staff member at the University of Western Australia. I've been working in the area of combustion science and technology since the 1980s, and I'm leading this project on the fluidized beta combustion of ammonia for stationary combined heat and power generation. Ammonia is a practical future fuel target as it is an excellent hydrogen carrier. It can be stored and transported at a room temperature and at relatively low pressures. And it is already a global traded mass commodity as an ingredient in fertilizers, industrial explosives, cleaning agent, and a precursor chemical for pharmaceuticals. Currently, ammonia is largely produced from natural gas or coal, and it can also be made using entirely renewable resources. It is an energy-intensive process, but the technology is mature. So it is entirely possible to make ammonia using renewable power from, say, wind or solar, and produce a completely carbon-free fuel. Burning ammonia as a fuel creates no carbon dioxide, sulfur, or particulate emissions. It has an energy density about half that of diesel, or a bit lower than natural gas. But its combustion characteristics are very different. To use ammonia directly as a fuel for heat or power generation, there are still technical challenges to overcome. It doesn't burn as readily as natural gas, for example. So it won't burn in a conventional power station furnace. We need to better understand how ammonia burns in high pressure, practically relevant conditions, so we can design reactors that achieve stable, efficient ammonia combustion at a large enough scale for power generation. At the same time, we need to better control the combustion chemistry to make sure the ammonia burns to produce water and nitrogen without emitting nitrogen oxides, commonly referred to as NOx. Our project aims to unravel the combustion characteristics of ammonia and the mechanisms for NOx formation, leading to the development of practical clean combustion systems using ammonia as a fuel for heat and power generation. Stage 1 of the project is designing and constructing a laboratory-scale fluidized beta reactor to study ammonia combustion, NOx emission, and the practical conditions. Fluidized beta reactors have been chosen as they are an established technology at both small and larger scale. Solids making up the fluidized bed provide a very stable heat source to help ignite and burn the ammonia controllably. And having the combustion reactions occur on an inert solid surface also helps suppress the formation of NOx. Our preliminary experiments produced only 10% of the NOx generated by burning ammonia in an open furnace. That's already less than what is normally produced when burning natural gas. Using this reactor, measurements of ammonia burning rate, heat release rate, and NOx emission will be made across a range of different ammonia and air mixtures, beta materials, and operating conditions. These experiments will be used to optimize the combustion process. The second stage of the project will develop a mathematical model of ammonia combustion in a fluidized beta reactor. Based on the experimental results, this will help us better understand the actual combustion process and allow us to predict the effect of a wide range of operating conditions on ammonia burning rate and NOx emission. This information can then be used to support pilot-scale reactor design. This 3-year project will unravel ammonia combustion chemistry and NOx formation and industrially relevant combustion conditions. This is a critical step towards developing medium and large-scale combustion technologies to use ammonia as a renewable carbon-free fuel for heat and power generation. So, why are we doing this? Developing the end-use technology for ammonia as a fuel for power generation doesn't only provide a path to clean energy for Australia. By harnessing our renewable resources like solar and wind to make ammonia, we can export renewable energy to the rest of the world too.